So hi everybody, today in this video I'll be talking about the topic of thermal expansion. So let's start by defining thermal expansion. Thermal expansion is the tendency of matter to change in shape, volume, and area in response to a change in temperature. This can be seen in all forms of matter, but it is most prominent in solids due to the tightly packed atoms. The cause of thermal expansion is that, as you can see from the pictures below, when particles are heated, they start to vibrate faster and their kinetic energy increases, which in turn causes the particle to move further apart, which also causes the substance to expand. This is also true in reverse, so the substance retracts when cooled. So the two types of expansion I'll be covering in this video is linear expansion and volume expansion. So let's start with linear expansion. Linear expansion can be described as a change in dimension or length of a solid due to change in temperature. The reason it can only occur in solid is because solids have a definite shape and can be measured. So take this railway track here. As you can see, there is a small gap in between the iron rails. This is because the workers are accounting for the linear expansion of the iron rails when the rails are heated due to the sun. We can calculate the linear expansion of a material using this formula right here of alpha times initial length times the change in temperature. Alpha is the coefficient of linear expansion, and every material and every solid has a different coefficient of linear expansion, as you can see from the table on the right. So let's say that that iron rail has a 100 length of 100 meters at 20 degrees Celsius. So what length will be at 40 degrees Celsius? We can simply put all the data we are given into the equation. Along with going by the table here, iron has a coefficient of 12 times 10 to negative 6. So we find out that the iron will expand to 2.4 centimeters when heated. But it is also important to note that the workers will have to put a distance of 0.048 meters apart. That's because the workers have to account for both of the iron rails expanding. Next, let's take a look at volume expansion. Volume expansions can be described as a change in volume due to the change of temperature. But unlike linear expansion, this can occur in all forms of matter, since all matter that has mass has volume. So the formula for volume expansion is similar to linear expansion, but instead we use the coefficient of volume expansion, which again has every material has a different coefficient. So for example, this tank here has 300 liters of water at 35 degrees Celsius. So how many liters will have at 70 degrees? Once again, we are simply just putting in all the data that we are given. And going by the table once again, we can see that water has the coefficient of volume expansion of 210 times 10 negative 6. So putting all that together, we find that the water will expand 2.205 liters when heated to 70 degrees. Lastly, in this video, I want to talk about thermal stresses. Thermal stress is the internal stress that is caused by the substance not being allowed to expand or contract freely, and it occurs in solids. So, going by the first example, the reasons that the worker has to put the gap in the railway was because of the linear expansion. But if the workers do not put the track in the railway and the iron rail are not allowed to expand freely, then that will cause the buildup of thermal stress, which can cause the rails to bend apart like in the picture shown here. We can calculate the equation of thermal stress using this formula right here, where E is the Young modulus constant of the material that we're given, and once again all materials have different Young modulus constants. So for example, the 100-meter piece of iron rail experiences a 30-degree change in temperature. Again, plugging in all the data from earlier along with the coefficient of linear expansion of iron, we find out that if the rail is not allowed to expand freely, the rail will experience 295,020 kilopascal of pressure.